Hi, my name is Jimmy Maletzis. I'm a welding instructor at Elgin Community College. Today we're going to talk about the 5 basic weld joints and some basic welding nomenclature for beginners welding. On this slide, today we're going to cover how to better understand the 5 basic weld joints. The 5 basic weld joints we're going to learn about today is called a butt joint. We can see here it's basically 2 pieces of metal butted up against each other with a configuration of a weld on top. The next joint's called an edge joint. We would literally be welding along the top edge or the bottom edge here. And it's an edge joint because these 2 pieces are standing up or laying down, whatever configuration, on edge. The next one is a 90-degree corner joint. And you can see where the weld is placed here. These shaded areas are basically representing a finished weld. The next one is a lap joint, 2 pieces of steel or whatever you're going to weld lapped on one on top of each other like that. And then finally, we come to the T joint. It's an inverted T. It could be a regular shaped capital T, or what you're looking to see where the weld areas are here. On this next slide, slide here, basically, I draw these configurations of these circles like this, and it kind of helps, better helps you understand what you're looking at as a finished weld. And I take these circles like this and I make 3 different configurations of lines. And in an A example here, I make a tic-tac-toe configuration. On the B, I make a vertical and horizontal line. And then I also do a crisscross here on the final circle here. We're going to shade these areas in and you're going to see what a finished weld would look like. On this next slide, before we can begin shading the circles, we need to that are going to represent the weld, what the weld's going to look like, we need to understand a few related words for welding. It's called welding nomenclature. A fillet weld. A fillet weld is basically a weld that has equal legs. If we look on this illustration here, the leg of a weld is the distance from the root of the weld is which is right here. The root of the weld is basically where the 2 base metals meet. And from that root, we're going to come all the way up to the toe. The toe of the weld is where the weld itself meets the base metal. So we're going to basically have something that's measurable from the root to the toe. This would be the top toe on a T joint. And from the root to this toe, which would be a measurable item. This item is configured. There's a formula to figure it out. But we could see that we are going to try to understand what the leg of the weld is, and these other items in here too: the toe, the face, and the root. So that could be. So this, basically here, this is we're going to take the first 3 of these 5 basic weld joints: the butt joint, 2 pieces of whatever you're going to weld butted together, the edge joint, and the corner joint. We're going to take that first A circle and we're going to shade this area in. And basically, you're going to think of this shaded area placed right on top here as your finished weld. So if you take this shaded area on the butt joint, on the edge joint, and the corner joint, that's basically what the finished weld is going to look like. If these configurations were vertically up and down, or this one was horizontal, or this corner joint was configured in a different direction, that would let you take one of these other shaded areas and place them on those welding joints. But in Welding 101, basically we teach what's called 1F, or a flat position. So everything's basically going to be flat on a surface that's suitable for welding. Welding table, a piece of steel, something, a safe area. So the butt joint, the edge joint, and the corner joint, you're taking that top tic-tac-toe area basically, and that shaded area, and you're putting it on that joint to see what the finished weld would look like. This next slide, we're going to look at the next 2 basic weld joints. The last 2 basic weld joints, the first one on the left is called a lap joint, 2 pieces of steel lapped across the top of each other. This happens to be a single fillet weld. So a fillet weld is equal legs, the same amount from the distance from the root to the toe here will be the same distance from the root to the toe here. And the same thing if you look on that's a single fillet. If you look on the T joint, this would be a double fillet. So we're actually basically taking this distance from here to here, toe to root, or root to toe here, and that's what makes these fillet welds. So if you go back to the lap joint, where the number 2 is, it just means that we've taken this vertical and horizontal lined circle, which is a B example, and we've taken this shaded area out, this kind of diamond shape, 1/4 circle here, and we've placed it right here on the top of the lap joint. This is a single fillet. If it was a double fillet, we would be taking the number 3 area and shading it in along with number 2. We would be taking the number 3 and placing it here, which would make that a double fillet. Because this T joint is already specified as a double fillet, we've taken number 1 shaded area and number 2 shaded area and placed them in this configuration right here, which makes it a double fillet. For example, this is basically another example. Final example is basically a non-basic weld joint. This is called an outside corner joint. It is also a fillet weld because from the root to the toe here and the root to the toe here is the same distance, which makes it a fillet weld. But this outside corner is kind of an interesting welding joint, and we touch over it in 101. It's configured at a 90-degree angle like this, flat on a table, still 1F. But it's a very strong welding joint. That's why we touch over it a little bit in 101, which would be the C circle. We've basically taken that crisscross and we've shaded this area in, looks like a diamond, and we've placed it on top or in between these vertical 45-degree lines. The next slide is now let's look at welding nomenclature. We need to understand there's many words like with any other trade, but one of the words that we use very commonly in our trade is called the axis of a weld joint. The axis of the weld joint is a line drawn from the root of the joint through the center of the face, splitting the toes in half. So we know what the face is, we know what the toes are, we know what the root is. Basically, we're going to just draw that line from the root where the base metal meets through the center of the face, splitting the toes in half. We're going to think about 2 different angles too. One of the angles that we use is called a work angle. It's the angle in which we point the electrode holder or an oxy-fuel torch to perform the weld on a specific weld joint. Travel angle, which is another angle that we pretty much use all the time, and we teach this to teach the students how to hold or point the either the electrode holder or oxy-fuel torch in the direction that they're going for each specific weld joint. So that's the angle, and either we push or drag the electrode holder on an oxy-fuel torch to perform a weld, electrode holder or oxy-fuel torch to perform a weld on a specific weld joint. So we have to understand that the weld joint, there's only 5 of them. The weld joint gives us the axis of the weld. The axis of the weld gives us the work angle, or the angle the electrode holder or oxy-fuel or oxyacetylene torch is held to perform a weld. The work angle will change based on the 5 welding joints. The travel angle will change by process, either push or drag. We'll touch on that in the next slide here. So we're going to first talk about the work angle. The axis of each one of these first weld joints are going to give us the work angle. So the axis of this weld joint, this is the butt joint, is we're going to take this imaginary line and we're going to draw it from the root, splitting the face in half, or splitting the toes in half through the center of the face. Everything that we weld with is going to, in a 1F or flat position, is going to start being 0 or flat on the table. And then we're going to take the consumable holder or the torch and hold it at a 90-degree work angle to perform this weld. So on the butt joint, the edge joint would be the same thing because we're taking a line from the root, splitting the face in half with the toe here and toe here, which gives us this 90-degree work angle. And then the corner joint is the same thing. You can see the toes. The root is here where the base metals meet. We're splitting the face in half, and that gives us this 90-degree work angle. And that should do it for that slide. The axis of the next two weld joints are as follows. So the next two weld joints we're going to look at here is the lap joint again. The lap joint is basically these two pieces of whatever you're going to weld lapped across each other, and then the T joint like we talked about. This is a little bit interesting here too, because if you look at, see where this toe is, it's at the top of this piece that you're going to weld, and this toe is the exact same distance. So if this piece of material is a 1/4 inch from the root to the toe here, being that it's a fillet weld you're performing, the distance from the root to the toe here also needs to be a 1/4 inch. If this was 3/16 from here to here, if it was 3/16 material, and from the root to the toe was 3/16 in a fillet weld, this would also have to be 3/16. So if we look at this picture, we can see that if we don't perform this weld by holding your torch or the consumable holder in stick welding at a 45-degree angle, you won't get this configuration from toe to toe to be equal legs. If you were to have a 90-degree work angle on a lap joint, the configuration would come from a circle and you wouldn't have a complete fillet weld because you needed to fill this whole joint up specifically. And the same thing on a T joint. If you took this T joint and held your torch or consumable holder, excuse me, and anything else but a 45, it wouldn't equally place the legs in a specific area that you need to do, which is from the root to the toe here, same distance from the root to the toe here. So basically your consumable holder or your torch is placing the material in a specific area by the angle that you're choosing to perform that task at. The next slide is basically, this is an image of an outside corner. Like I say, it's not one of the 5 basic weld joints, but it is it's a very common welding joint that we see in the trades. It's one of the strongest welds there is. What makes it one of the strongest welds is if you look here where the root is, there's basically nothing underneath here. There's no other piece of steel or anything. So by welding in this configuration at a 90-degree work angle, you're getting maximum penetration, which is basically filling the whole complete joint with weld. So it's a very strong weld. It's a very common weld. We kind of touch over it in 101 a little bit, but we get more intense in the outside corners in the other 102 and welding 3 and stuff like that. But to realize how we would hold our consumable holder or our torch, we're going to do the same thing. This is a 90-degree outside corner. We're going to identify the root where the base metals meet. We're going to split the toes in half with this line that goes right through the center of the face, knowing that we're starting from 0 plane. That gives us that 90-degree work angle. Next, we're going to talk about the travel angle. What the travel angle is basically, what is it? It's the angle that we hold either the oxyacetylene torch or the stick process consumable holder in to perform the task. In oxy fuel or oxyacetylene process, we're going to use a 45-degree push angle. So we're going to hold that torch 90 degrees to perform the weld, but we're going to point it in a direction that we're traveling. So in this left hand illustration here, if we are right-handed, we would start on the right for oxy fuel and push it to the left as we're going in this direction to perform this weld. You can see the way this arrow is depicting. But in stick welding or shielded metal arc welding process, we are going to drag this process along, but we're only going to be dragging it along in a 5 to 15 degree angle. To figure out where the travel angle starts is, like we talked about in the work angle, starts from the horizontal plane where the piece sits. The travel angle starts at a direct 90-degree angle perpendicular to where we're going, and it's pointing in a direction of travel. So in the oxy fuel or oxyacetylene, we are pushing the torch in that 45-degree travel angle with a 90-degree work angle. And in this illustration, we are dragging in stick welding or shielded metal arc welding, we are dragging only in 5 to 15 degree. And there's other reasons for these angles, which we would get in a little bit more detail in the class. But these are the two travel angles. One is push, one is drag. So in review, let's kind of go over what we've learned here. We've learned that there are 5 basic weld joints. These 5 basic weld joints are butt, edge, corner, lap, and T-joints. If somebody was to say, hey, it's an edge weld or a corner weld, it's not. It's a joint. There's only 5 joints to remember. These welding joints, basic 5 welding joints, can be broken down into many other configurations. It's kind of like a Christmas tree with the 5 basic welding joints at the top, but they pyramid out as they go down, become more complicated welds with a little bit more information in it. We also learned that if you want to visualize what the finished weld would look like, we could take a circle and we could take segments from the circle to help us visualize, what the finished weld should look like by placing it on those weld joints. The first 3 butt, edge, and corner welding joints would take that A circle, and the lap and T would take that the second or the B circle with the horizontal vertical lines, and then we also touched over the outside corner, which is the third C example circle, and you would take that top diamond shape and place it in there. The axis of the weld joint gives us the work angle, and the welding process will determine the travel angle. Oxy-fuel or oxyacetylene would be push 45, and the shielded metal arc would be a drag angle, 5 to 15 degrees. Hope this helps. Thank you for your time.